Hi everyone, my name is Ayush and I'll be presenting this paper Live Repetition Counting by Ophir Levy and Learworth. This is basic outline of the presentation. We'll look at the motivation, discuss the proposed methods, look at their experiments, and then discuss results and conclusions. So given a video, we'd want to detect how many times a certain action has been repeated and where the action repetition starts and where it ends. So given a sequence of frames, the authors use CNN to detect length of an action, and they count how many times this action has been repeated within given video, and then do automatic segmentation of the repeated action from other unrelated frames. The other motivation is to train this neural network on a synthetic data so that this model can be generalized to other data sets and make it a real-time system. So for the overall system, they take a sequence of 20 frames. This sequence is sampled at a fixed interval, so they skip a fixed number of frames in between. And for the entire video, they take such 20 frame sequence using a sliding window. Once they have these 20 frame sequences, they pass each one individually to the convolution neural network, and the network will give them a prediction of the cycle length. This cycle length is predicted for each block individually and then passed to the outer system. This outer system is responsible for counting how many times the action has repeated and also doing the segmentation for starting of the action and end of the action. Now we look at the CNN architecture that they have used. They take 20 frames and resize it to 50 by 50, and they perform convolution on it to get 40 feature maps. We see that the convolution kernel is 5 by 5 by 20, so they encode the entire 20 frame sequence into a single feature map and get 40 of those feature maps. Then they perform a max pooling, but we see that in max pooling they don't use temporal pooling, so they only reduce the dimension spatially. This is followed by two other convolution and max pooling layers, and by the end we have 90 feature maps of size 4 by 4. This is followed by a fully connected layer of size 500 and then to another fully connected layer of size 8. This output 8 layer corresponds to, each node corresponds to one cycle length between 3 to 10. So they're classifying, given a 20 frame video, what's the cycle length of a repeating action. So if they get 5 here, then it means an action is repeating every 5 frame in the given 20 frame video. They apply a softmax to this and use cross entropy for loss. Once this convolution network is trained and ready, they take for testing, they take a video block of 20 frames, pass it to the CNN, and they get a y hat, which is the predicted cycle length from this classifier, and p is the vector of 8 prediction scores given by the softmax layer. Since it's a classification problem and they classify between 3 to 10 possible cycle length, they don't have a way to determine how to see if there's actually an action repeating in the given 20 frame. So to do that, they say they use this function to get the entropy, and they experimentally verify that for those sequences where there's actually an action repeating in that, the entropy score will be very low. So if the classifier is predicting with very high accuracy for one of the 8 cycle length, then in such cases this entropy will be low.
So they get output as a 8-dimensional vector, right? And these are the probabilities.
Yes, from softmax.
So that cycle length 3,
yes,
or 4, or 5, and all those things.
Yeah.
And using that probability vector, then they find whether to rely on that.
Yes.
Apply threshold
Yeah, if the entropy is above certain threshold, they ignore such blocks.
Which means that there's a lot of chaos. Not good.
Then we look at the outer system. The outer system consists of the predicted cycle length from CNN and the vector of 8 prediction score for each block. Then it has R, which is the number of repetitions counted till that frame, and C, which is the number of frames since last time R was updated. So we see that C is updated every valid block and R is updated whenever they detect a valid repetition.
So first go through the first row. There are 9. What is 9? Why?
So for y hat, for each block, they get a prediction score from the classifier, and they assign this score to the first frame of that block. So
So each frame is actually represented 20 frame block.
yeah, 20 frames starting from,
They found out that a 9 cycle length is the highest probability.
yeah,
And the next one is 9, the next one 9, and so on.
yeah,
And then we found that other one is 8.
yes,
Yeah, so that is the y head predicted cycle length for all these blocks.
yeah.
Then we go through the other two things.
So yeah, so we'll go to how they implement the counting system on this. So to detect the starting point of a repeating action, they take average entropy of last 7 blocks. So they take 7 consecutive blocks, and if
I thought you were going to explain the R and the other 3 things.
comes after this,
Explain R.
yeah, after. So once they have the average entropy of last 7 blocks, then they say if this is less than a certain threshold. If the average entropy is less than a threshold, then it signals that a repeating action has started. So for example, for this block, if we assume that the last 7 blocks in average entropy is less than threshold, then they start counting the number of times an action has repeated. This is denoted by R, and they use floor of 20 by the current predicted cycle length. So in this case, the current predicted cycle length is 9. So by the time they get, because this is a moving average, so by the time they get to this block, they have already, the action already has repeated a certain number of times before this. So to get that, they take floor of 20 by the current predicted cycle length. And also for each block, we notice that the predicted cycle length is consistent. It's 9, 8, 9, 8, 7, and 10. So if an action is repeating for a certain number of frames, then this prediction stays somewhat stable. So relying on that, they just take floor of 20 by the current predicted cycle length. So here in this case, 20 by 9 is 2, floor of this, and sees the counter to see how many frames has passed since the last time R was updated. Is 20 modulus y, and in this case 20 modulus 9 is also 2. Now to continue this counting, once the average drops below a threshold, for each consecutive block they check whether the
So how do you get the 3, the next one? How do you get 3?
that comes,
Will come.
yeah. So for each valid block after the counting has started, they will increment the value of C by 1. So if it starts from here with 2, then this block is valid, means the entropy of this block is lower than a threshold, and they increase value of C. They do that for each valid block thereafter. And to signal when an action has repeated, they check if this counter is greater than or equal to median of the last 4 predicted cycle length. So when we are in this frame, C will become 9, and the median of last 4 predicted cycle length is also 9. So it signals that an action has repeated, and they update value of R by 1, and they reset the counter to 0.
Okay, this is very complicated, so just slow down and so people understand. So Y hat is very easy, right? That's coming out of the network, which is cycle length.
Yeah.
So then R, you're saying, which is also easy to divide 20 by 9 to get the flow of that.
That's for the starting.
Then what is the when does when we change that?
R.
Yeah.
So R is only changed if C is greater than median of last 4 predicted cycle length.
So then so what is the R? Can you go back to that formula we had? How you define R and C? Okay, so then C is computed from 31 Y head, right? And C represents what?
C represents the number of frames since repetition was last encountered.
So yeah, because it's not that clear. So again, go through slowly. That
Okay.
from here you get 9, and then you get the R. First one is R is 2, and then C is 2.
Yeah.
Right? So then when it changes, C becomes 3. Then what does happen?
So after the starting block is identified, for each valid block, the value of C is added by 1.
Okay.
And the value of R is only changed when C is greater than or equal to median of last 4 predicted cycle length.
Okay, so they look at last 4.
Yeah, so they look at the last 4 Y hat.
Somehow there are a few other ones, that's why they change here.
Yeah. So in this case, value of C jumps from 8 to 9 for this frame, and the median of last 4 Y hat is 8, 9, 9, and 9, which is 9. So since C is equal to the median, they say it signals as a repeating action. So they increase counter of R by 1 and reset counter of C to 0. So you can see that happen again in this frame. The value of C goes to 9, and the median of 8, 9, 9, and 10 will also be 9. So they update counter of R and reset C again.
Value of C is 8.
No, for this frame, when they move to this frame, they increase it first.
So, but where is it? I mean, value of C is 8, and it becomes 0.
Then in this frame, it will become 9.
9.
Yeah, and if they increase the value of R, they reset C to 0.
Oh, I see. Start from 0.
Yeah. Now to detect the end of repetitive motion, they use similar approach. They take average entropy of last 7 blocks, and if the average has risen above a threshold, they stop counting. Now to handle actions which happen at different rates, so they can be rapid action, moderate action, or slow action, and they cannot predetermine this in a live video, so they use multiple detectors with different sampling rate. So they use 2 for rapid actions, a sampling rate of 5 frames per moderate action, and 8 for a slow occurring action. So if it's a sequence of frame, 2 is sampling every other frame, 5 is sampling every 5th frame, and 8 is sampling every 8th frame from the input sequence. To count the number of repetition, they have 2 modes. One is offline, which is taking the whole video at once, and they run this detector on the whole video and count at the end. In this mode, for each of the previously described detector, they run it with a sliding window on the whole video and find average entropy for each detector, and whichever detector gets lowest average entropy is selected. So they use the count from that detector valid for this video sequence.
So these detectors are the sampling, different sampling.
Yes.
The 2, 5, and 8.
Yeah. And for online mode, which is live mode, they use sliding window of all 3 detectors, and at every 40 frame, they calculate the average of all 3 detectors entropy and use the one with lowest average. If this lowest average is less than a threshold, then they use the number of repetition given by that detector and update a global counter. Then they reset all these counters and do for the next 40 frames.
So what is use sliding window on the decoder? They're not doing sliding window in the offline mode?
They do it there too, but in offline mode, they use one detector, do sliding window for the whole video, get entropy for all the possible blocks. Then they use another detector and do for the whole video.
Okay.
But here they do it for 40 frames at a time.
So there's all 3.
Yeah.
Next one.
Yes. Besides the system, they also discuss about ROI detection, which does not actually involve any learning part. So given a 20 frame sequence, they use for each pixel, they take standard deviation. This will help to identify pixels with motion, and they threshold it at mean. So only pixels which correspond to motion are selected. This threshold gives a binary map.
So slow down. You're going too fast.
This
So one is that they're not using the whole frame, right? So they want to use the ROI, user interest, to do this thing, and which is better than using the whole frame.
it's because
Show the results.
yeah. So to do
Go back again and just slowly explain this.
so for a given 20 frame block, they take standard deviation for each pixel in time,
Temporarily.
in temporal domain, and then they threshold the resulting 2D-dimensional map at the mean value of standard deviation. So now they'll get a binary map of pixels which correspond to moving motion pixels, I'd say. Once they have a binary map, they use a 10 by 10 convolution kernel of all ones.
So this is go back. Just go back. So this is showing the pixels which are ones that their descent deviation was more than the mean of this, right?
Yeah.
So these shows temporarily these pixels are changing resolution.
Yeah. So once they have this map, they apply a 10 by 10 convolution throughout this whole map, and they get, after they do a 10 by 10 convolution, they get another map, but that's not binary, and they threshold that map again, only to select those pixels with very high activity regions. So once this map is present, generally they can take the bounding box fitting this map because it represents motion pixels. But the authors say that if they sort the indices and take the index at 3rd and 97th percentile, that represents a tighter bounding box instead of just taking the entire region. So they sort all the indices from this previous map, and if they don't detect any boundary or any valid boundary, they use entire frame as ROI. So given a 20 frame sequence, the ROI detection will give some region, and the input to the network is only this region cropped for all 20 frames. So
So this is a fix. Even when the person moves moves, then it will not change.
Yeah, within this 20 frame, this stays fixed. For the next 20 frame, they do a detection again. So for these 20 frames, with just around that region, and it is converted to grayscale and resized to 50 by 50 to feed it to the network. Now, their data, they use a synthetic data set for training their samples. The synthetic data consists of patterns overlaid on white noise background, and the patterns have cycle length between 3 to 10, so they repeat every 3 frame, 4 frame, like that to 10 frame.
So this pattern moves, like there's a pattern in first frame.
Yeah.
It moves to the next frame.
Yes.
And then
they have 4 different motions.
There's 4 different motions.
Yeah, they have like linear motion, circular, and like shrinking and growing. So here we see in this row that there's a pattern. There's a pattern in this frames, and it's repeating every 3 frame. Similarly, they have a sample with repetition at every 4 frames, and so on to 10 frames.
So the whole pattern moves are little.
These boxes inside the pattern move. These.
And each moves separately, or the whole thing moves? So
I think they have variation of that. So they take 30,000 of such training sequences and 5,000 for validation, and they train for 102 epochs on a GTX 580. They stop at 8.5% validation error. To do benchmark of their method, they take 100 YouTube videos. They manually select these videos, and it consists of exercising, cooking, building. So this is a sample of the video where there's a repetitive motion. And the metric used is absolute difference in count. So here G is the ground truth for number of repetitions, R is the number of repetition given by their system, and they take a percentage of this. So for online mode, to test on real-time system, they select, out of the 100, they select 25 videos which have non-repetitive segments before and after, so it's not a trimmed video. And they have, they record an hour-long video with 44 different actions in it. So here are some results. This is on the entire YouTube benchmark. Here, full means the entire system that they defined. No ROI is the one where they don't use ROI detection. Regression is a variation of their convolution network, where instead of classifying at the end, they use a regression.
So they'll come up with a number, and
Yes.
cycle as 3 or 4.
And they use Euclidean laws to train that regression. 3 is a previous paper which deals with pattern analysis, is cited here. Moving full here refers to videos where the camera is moving. And
So they, from the 100 video, they identify some videos in which camera is moving. What is the last one?
the moving video could be, I think it's a set of videos where they have static motion. They say they have 30 videos in the 100 videos where they are like static,
Moving.
the camera is moving, it's not
So
static.
they report separate results for that.
Yeah, just for those set of 30 videos.
Good.
Manual selection means they select the sampling rate manually for the detector, and they get very low error in this case. And we see that the full system and the system without ROI detection perform very similar. So ROI detection has a minimal effect on this system right now. In offline selection, they run all detectors throughout the whole video and pick the one with lowest entropy at the end. So compared to manual selection, offline selection performs a bit worse. Online selection is running it in live mode, so they take the reading at every 40 frames and average it there. And detector median means they take median of the 3 detectors they choose and use the score from that. They also run the same test in a reverse, so they try to see if they can detect repeating pattern given the video in reverse, and it seems very similar. This is another set of result. Here this YTIO refers to 25 videos where they have non-repetitive action before and after the video. So it's untrimmed video, and live is also 1 hour long untrimmed video. And this true positive, false positive refers to the actions, not the number of times they count repetition. So they say out of 25 videos, they can find repetitive action in all of them. But for live, they miss one action. And they also have some false positive detected. Then this shows the start and end time of their system. This is compared their prediction compared to the actual start and end time of an action. And rewound means, since they are using moving average, sometimes they count one more repetition at the end of the cycle. So in such cases, they cancel the last count. Perfect counting here means they counted the number of repetitions correctly, and they only have 15 out of 25 and like 24 out of 44 with perfect counting. This is counting with 1% error, and this is with 10% error. Here are some results from the video.
So linear hypothesis means what?
So when they initially start, they say this is starting of a repetitive motion. They don't immediately start counting. They take moving average, and if the entropy stays low for 4 consecutive blocks, then they say it's a valid repetition and they count.
So the action 1 means what? There's only one action.
One action detected.
On their video, they are different.
The live videos, they say, have 44 actions in the same video.
Same video, right?
Yeah.
And they are able to detect those? Like this is different action?
Yeah. But in the limitation, they also say that it doesn't work with multiple actors, and the rate at which action happens depends on the rate. The detection depends on the sampling interval they select. That's why when they do manual selection, they have like best performance compared.
Manual selection means they just
Select a manual interval sampling rate.
and looking at the video.
Yes, based on the video.
Mm-hmm.
That's it.
Okay, very good.